Chapter 1.13.2.1 Custom Resources. Summary. Custom resources expand the Kubernetes API and enable data storage and structure beyond the core functions, enhancing modularity and customization capabilities. They can be used alone to store data or with custom controllers for a declarative API approach. Choosing between them and standalone services depends on customization needs and project complexity. Custom controllers paired with custom resources form a declarative API, enabling Kubernetes to ensure resource states match the defined desired state. This differs from imperative APIs, which require explicit actions. Admins can deploy or update custom controllers independently from the cluster, enhancing flexibility in managing applications. Kubernetes can integrate custom resources using custom resource definitions, CRDs, or API aggregation. CRDs are easier, suitable for simpler needs, while aggregated APIs offer flexibility for tailored behaviors. Field selectors in CRDs enhance resource management, allowing for specific instance retrieval. Careful planning ensures resources don't overload storage capacities. Custom resources. Custom resources extend the Kubernetes API. This guide covers when to add a custom resource to your cluster versus using a standalone service. It explains two methods for adding custom resources and offers guidance on choosing between them. Custom resources. A resource in Kubernetes is an endpoint storing API objects, such as pods. A custom resource extends the Kubernetes API for customizable installations. Custom resources now form core functions, making Kubernetes modular. They can be dynamically registered and updated independently by admins, accessed via kubectl. Custom resources enhance core functionality by enabling dynamic registration and independent updates by cluster admins. They are accessible using kubectl commands like built-in resources. This allows for a customizable Kubernetes installation to fit specific needs. Using custom resources, Kubernetes becomes more modular, easily integrating customizations. They appear, disappear through dynamic methods and cluster admin updates. Installed resources are accessed with kubectl, similar to regular resource objects like pods, enhancing Kubernetes installation with specific custom needs. Custom controllers. 1. Custom resources help to store and access data in a structured manner. When paired with controllers, they form a declarative API, which divides responsibilities. You state the desired resource state, and controllers sync it with the current state. 2. This setup contrasts with imperative APIs that give direct instructions. Custom controllers, independent of the cluster lifecycle, are adaptable. They optimize resource management. 3. Custom controllers are versatile and effective, especially with custom resources. They can be deployed or updated anytime, enhancing cluster operations. 4. The operator pattern combines custom resources and controllers, applying specific knowledge to extend Kubernetes APIs. This approach provides flexibility and specialization for applications. Should I add a custom resource to my Kubernetes cluster? Creating APIs involves decisions like whether to merge with Kubernetes APIs or remain standalone. Declarative APIs feature small, infrequently updated resources that define app settings or structures. Transactions aren't needed as the API shows the desired state, and operations mainly involve creation, reading, updating, and deleting, CRUD. Declarative APIs don't involve transactions across objects, representing only the desired state. Imperative APIs, by contrast, aren't declarative. If your API requires responses after client actions, involves RPCs, or stores large data quantities, it's likely not declarative. Should I use a config map or a custom resource? Use a config map for well-documented formats like mysql.cnf in pods to ease program configuration. Prefer files, environment variables over the Kubernetes API. Ideal for rolling updates via deployment. A secret is similar but for sensitive data. Choose a custom resource, CRD, when you need Kubernetes CLI, library support for new resources. Ideal for creating, updating resources using kubectl, enabling automation for object updates, and following API conventions, spec, status, metadata. Acts as an abstraction over controlled resources. Config maps are ideal when you have a single configuration file to be consumed by programs in a pod and prefer simpler access methods like files or environment variables over direct API usage. Secrets provide a secure equivalent to config maps for handling sensitive data, leveraging similar functionality while ensuring confidentiality. Utilize CRDs when you require complex interactions, automation, and a higher level of control over Kubernetes resources, especially when adhering to established API conventions is necessary. Adding custom resources. Kubernetes offers two custom resource options, CRDs and API aggregation. Custom resource definitions, CRDs, don't require programming and add new resource types easily. API aggregation involves more programming but allows flexibility. It's used for advanced control. Kubernetes gives flexible options, balancing ease of use and advanced control needs. Avoid using custom resources for data storage. Prefer loosely coupled architectures. Custom resource definitions. The custom resource definition, CRD, allows you to define custom resources in Kubernetes. By creating a CRD object, you're making a new custom resource based on your desired name and structure. The API takes care of storing and making your resource accessible. Important tip. Ensure names follow DNS subdomain rules, whether it's the CRD name or an object under it. Using a CRD simplifies the creation of custom resources as you don't need a separate API server. However, this means fewer customization options. For practical use, refer to examples, like the custom controller, for guidance on registering, managing, and controlling your new resource type in Kubernetes, allowing you to handle events effectively. API server aggregation. Kubernetes usually requires specific code to handle REST requests for each API resource and manage their storage. The primary API server does this for built-in resources such as pods and services. However, it can also manage custom resources using CRDs, custom resource definitions. The aggregation layer in Kubernetes lets you implement custom APIs by creating and deploying your own API server. When a custom resource is requested, the main API server forwards the request to your server, making it accessible to all Kubernetes clients. Choosing a method for adding custom resources. CRDs offer simplicity, making them suitable for small-scale projects or internal resources. They're easier to create than aggregated APIs. Aggregated APIs provide advanced features and greater flexibility, allowing for customization of elements like the storage layer. Both CRDs and aggregated APIs enhance API features on Kubernetes, providing more than implementing externally. Preparing to install a custom resource. 1. Potential points of failure. While custom resource definitions, CRDs, themselves don't directly introduce new failure points, they often come bundled with third-party code. Care should be taken with packages that deploy this code, as they can add complexity and potential issues. 2. Impact on storage. Custom resources, similar to config maps, consume storage. Adding too many might strain the API server's storage capacity. This concern is valid for both main and aggregated API servers if they share storage. 3. Authentication and authorization. CRDs use the existing authentication and authorization systems. New roles might be necessary for access since typical RBAC roles won't cover new resources unless explicitly granted. 4. Audit logging. CRDs follow the same audit logging protocols, ensuring traceability. Aggregated APIs may vary in this regard, depending on configuration. 5. Role and permissions bundles. Newly added CRDs and aggregated APIs often include role definitions in installation bundles to facilitate access and permissions management for their custom resource types. Accessing a custom resource. Kubernetes client libraries enable accessing custom resources, though not all libraries support them. Notably, the Go and Python libraries do. Custom resources can be accessed using several methods: through kubectl, a dynamic Kubernetes client, or a REST client tailored for it. Creating a client using Kubernetes tools is complex, yet some projects offer generated clients alongside the CRD or AW. Custom resource field selectors. This YAML code defines a custom resource definition, CRD, named shirts.stable.example.com, for a Kubernetes cluster. It specifies the group as stable.example.com, scope as namespaced, and includes fields for color and size under the spec property. It also sets up additional printer columns for color and size based on the specified JSON paths. This code is querying a custom resource called shirts.stable.example.com and filtering the results based on a field selector that specifies the color blue in the spec color field. The kubectl command will return any instances of the custom resource with the color field set to blue. This code snippet likely represents a custom resource named shirts, with fields for name, color, and size. It is showing two instances of the custom resource, labeled example1 and example2, both with the color blue and differing sizes S and M. Field selectors enable users to filter custom resources based on certain fields such as metadata.name and metadata namespace. Additional fields can be made selectable through custom resource definition. This feature is in beta in Kubernetes version 1.31 and is enabled by default. In Kubernetes version 1.31, you can declare selectable fields in the spec versions, selectable fields of a custom resource definition. This allows additional fields like spec, color, and spec size to be used in field selectors for more customized resource selection. Example. In the shirt resource definition, YAML, fields such as spec, color are declared selectable, allowing retrieval of resources that have specific attributes such as a color of blue.